Good morning. This is going to be Unit 11, Sequences and Series, Day 4, primarily talking about the binomial theorem. Okay, so I'm going to go ahead and skip the warm-up. If you wanted to check your answers, you can. But I'm going to go ahead and start talking about this binomial theorem. So the binomial theorem is used to help expand binomials to powers higher than 2. Okay? If the binomial was just to the second power, you would probably just FOIL the problem and do that. So you're going to use Pascal's triangle to help you with that, okay? So Pascal's triangle is this here, and notice that each new row, it starts with 1, 1, 1, and then to get this next row, you add up these two above it. So they all start with a 1, and then you add up 1 plus 1 gives you 2, and then 1, technically there's a 0 there, gives you 1. So for example, if you went to any row, this 10 is created because the two entries above it are 4 plus 6 gives you 10. Okay? This 3 comes from 1 plus 2 gives you 3. So you can create Pascal's triangle if you needed to on the test and draw it out. But another way that is a little faster, since this is going to be a calculator active test, is to create any row that you want of Pascal's triangle using your graphing calculator. So to create any row, and we'll just I'll put it here so that we can check. So on your calculator, you're going to go to your y equals, and on your calculator, say you wanted to create the 5th row. So if I wanted to create this, like how would I get those numbers 1, 5, 10, 10, 5, 1? So you type in the row that you want, so that's row 5, and then you go to the math key. Let me scooch up so you can see. And you go to the math key, and you actually have to arrow over until you highlight that probability tab, and then go to choice 3, NCR. That's a combination. So you select that, and then your calculator puts it in there with the 5, and then you're going to put an X. Okay? So this is going to generate that. So then you do second table, okay? And you'll notice that if you look at the Y column there, you get that 1, 5, double 10, 5, 1, and it's exactly the same as row 5 here. So to generate any row of Pascal's, you hit Y equals. Say then you wanted the 7th row. So you could go in there and hit 7. Again, you could do math, arrow over to the probability tab. It's choice 3, right? And then you do an X for the other one. Well, that got some other stuff in there, but so math, probability, okay, choice 3. If I wanted the 7th row, it would be 7, and then you put an X just using that variable key, and then you look at the table, and then you can see it's that 1, 7, 21, 35. You get that in that Y column, okay? So once you know how to generate any row that you want of Pascal's triangle, it becomes pretty easy, okay? And we want to see if this works. So expanding binomials, so this is a binomial. Remember, binomial, there's two terms. And normally we would just use FOIL. So we know that that squared is just that times itself, right? That's what squared means. And if you were FOILing this, you'd say, oh, that's x squared, and you get minus 8x minus another 8x plus 64. You'd combine like terms, and your final answer here would be x squared minus 16x plus 64, okay? So now I'm going to say, is there another way that I could get the same answer using Pascal's triangle? So whatever this exponent is, that's telling you which row to use. So I'm going to use row 2. So you go to row 2, or if you had to get it on your calculator, you'd find row 2 on your calculator, using your calculator. And then these become almost like the first thing you're doing. So you write a 1, leave yourself some space, a 2, leave yourself some space, and then another 1. Okay? Then what you do is you take this first thing and you put it in parentheses, and then you put the second thing in parentheses, plus. And then you do the first thing, the first term, and the second term. And then after this one, you put the first term and the second term. Okay, so you write that after each turn, and then you just count down. So you start with whatever the number this is, you start as the exponent on the first term. So you say this is 2, 1, 0, and then you count up starting at 0 on the second term. So it's 0, 1, 2. Notice that the sum of the exponents, so 2 plus 0 gives me 2. 1 plus 1 gives me 2. 0 plus 2 gives me 2. That's going to work out every time. And now you just simplify this. Well, we know that x squared is x squared, right? Times 1 is still x squared. And anything raised to the 0 power is 1. So you have 1 times x squared just leaves you with x squared. Now you have negative 8 to the first power is negative 8 times 2 is negative 16. X to the first power is just x. And then over here, recall, anything to the 0 is 1. So you have 1 times 1, and then that squared is a positive 64. Notice you get the same exact answer. Now, clearly, if this is just a 2, then foiling is a bit easier. Okay, so I would just FOIL. The problem, or rather the advantage to using Pascal's triangle, comes with examples like 3 and example 4. When this power is something bigger than a 2, then your foiling gets very, very messy. Okay, so we're going to go ahead and try another example. Now, though, we're going to be using the fourth row of Pascal. So you go to row 4. So these are the kind of the coefficients that I'm going to use, and I always just kind of space them out. So it's 1, leave yourself some space, plus 4, leave yourself some space, plus 6, space, plus 4 again, space, plus 1, and some space. Now you take the first term, so I'm looking at this x, and I put that in parentheses, and then it's a positive 2 in parentheses, and I write that next to each one of those. So I just drop them in, and I'm just recopying them. X, and then a 2, x, and then a 2. Okay, so notice in this first example how it was a negative 8, so I had to bring the negative 8 here. It's a positive 2, so the sign there is positive. And now you start with this exponent, and you count down. So I start with 4, and then you say 3, 2, 1, 0. Notice it goes from 4 all the way to 0. That's going to happen every time. And then on the second term, you start at 0 and count your way up. So 0, 1, 2, 3, 4. You check to make sure that the sum of each set of exponents adds up to 4. So I'm good. And now you just simplify. Anything to the 0 power is 1. 1 times this one is 1. So here I'm left with x to the 4th power. 2 to the first is 2. 2 times 4 is 8, so I have positive 8x cubed. Next, 2 squared is 4. 4 times 6, 24. So 24x squared. 2 to the third is 8. 8 times 4 is 32. So plus 32x. Anything to the 0 is 1. So you have 1 times 1 times whatever 2 to the 4th is. Well, 2 to the 4th is 16, so it's just a plus 16 there. And now you have that expanded. So clearly if it's just a 2, it's easy to FOIL it. But if you get this to be a 3 or a 4 or a 5, then it's going to get really, really hard to FOIL that out a million times, so this is a better method. Okay, now a little bit harder. Notice how in this example, it was just a monomial part there. It was just like an x or just a 2, but now it's a 3x. So you're going to have to be very, very careful with your parentheses here, okay? So the first thing I do is figure out what row of Pascal's I'm using. So I'm using row 5. So go back to row 5. Okay, so you're looking at row 5. So I leave myself some spaces there. So I start with a 1, leave yourself some space. Plus, row 5 then has a 5, space, plus 10, space, plus another 10, space, plus 5, space, plus 1, space. All right, now you're going to go and you write each thing in parentheses. So it's a 3x in parentheses next to a negative 4. Write that next to each one of those terms from Pascal's. Watch your parentheses. We're keeping them in parentheses. 3x and a negative 4. And last there, 3x, negative 4. Okay. Now we need to go back and put the exponents. So you start with 5. You count down. So 5, 4, 3, 2, 1, 0. So I'm just working with the 3x terms. Now you start at 0, count your way up. 0, 1, 2, 3, 4, 5. Now it's simplifying. Anything to the 0 is 1. So you've got 1 times this coefficient of 1. And then be careful. Over here, this is 3 to the 5th power and x to the 5th power. So if you need, some help from your calculator or something, then use it. So you've got 3 to the 5th power is 243. So it would be 243 times 1, which is just 243, x to the 5th. Now you have to do this one, okay? So if I was doing this, I'd say, all right, don't forget this 3 is raised to the 4th power too because it's in parentheses. So it's 3 to the 4th, and then multiplied by 5, and then negative 4 to the 1st power is negative 4, so multiply that by negative 4, okay? So you have negative 1,620 x to the 4th, right? Because there was still x to the 4th there. And you're just going to follow that process down the entire polynomial there. So some of them you can kind of do in your head. So plus 3 to the 3rd power is 27, right? So then you have 27 times 10, right? 270. 270 times 16. So 270 times 16 gives you 4,320. Now check your variable. It was x squared. Oh, I'm sorry, x cubed. I misspoke, sorry. Notice that your exponents are going 5, 4, 3, right? So they're kind of following that pattern. That should help you along. So you're going to continue in that fashion. So you have 9 times 10, right? So you have 90 multiplied by whatever 4 to the 3rd power is. So you've got 4 to the 3rd. Now be careful, it's going to be negative though, because it was a negative. So you've got that 64. So it would be negative 64 multiplied by, what did I say? Something like 90. So that gives you negative 5,760. So you got negative 5,760 x squared. Going down to this side now. So you have negative 4 to the 4th power. Okay. So that gives you 256. And then times 3 to the 1st, which is 3, times 5. So times 3 times 5, or 3. So it was going to be positive 3840 x. And then the last one, anything to the 0 is 1. So really you're just going to do negative 4 raised to the 5th power. And that gives you negative 1024. Ooh, I barely fit that on there. Okay. So this is your final answer there. That's as best you could do. Keep in mind that I can ask you multiple questions on the test. Maybe on the test it says something like, sorry, the bell's ringing. Maybe on the test it says something like, what is the coefficient on the x squared term? So if I said, what's the coefficient on the x squared term, you would have to find the x squared term and say the answer there would be negative 5,760. Or I might say, what is the 4th term in the sequence? So then you only, the answer to the 4th term would be negative 5,760 x squared. So just be careful on the way that the question is asked. Okay? Flip it over to the back and we'll have some more examples. Okay? So the more complicated the terms are within the binomial, the kind of more messy the problem is going to be. you'll notice here that they're asking you to use the 6th row of Pascal's triangle. Okay, so if you're using the 6th row of Pascal's triangle there, the coefficients you're going to be working with, right, it's going to be 1, and then your next one is going to be 6, then 15, etc., etc. So I'm going to kind of do the setup for this one. So 1, and then in parentheses it's going to be 2x, and it'll be to the 6th, negative 3y, and that'll be 0. Again, if you like it kind of the pattern way, plus, and then the next coefficient from Pascal's was 6. And then I put each of those in parentheses. Make sure you're watching that negative there. And then plus 15, each one in parentheses. And then 20, each one in parentheses. Now I'll go back and do the exponents in just a minute. I'm going to have to go to the next line because I wrote too big. So 1, 6, 15, 20, and I just want to see, yeah, after the 20 is another 15, so I'm just going to go down here, plus, again, this is continued, okay, and then plus 6, 2x, and then a negative 3y, and then 1, 2x, negative 3y. Okay, start with whatever this exponent is, that's where you start. So it's 6, 5, 4, 3, 2, 1, 0. Okay, and then on the next one you start at 0, count up. So it's 0, 1, 2, 3, 4, 5, 6. Okay, so you've got that. Then from there, it's just cleaning it up. So go ahead, try to kind of clean that up and see what you get there. One tip that I will say is if you kind of see you're getting some of these negatives, notice it's going to go positive, negative, positive, negative. So it's going to kind of keep alternating there. Those of you that are kind of good at looking for patterns, a lot of those are going to kind of work well for this. Kind of check your answer as you clean it up. I have to go on to this next line because I didn't write small enough. Okay, hopefully you've kind of caught up and yours simplified to the same as me. Remember, you have to do 2 to the 5th power multiplied by negative 3 multiplied by 6 to get that. Okay? Alright, so that's about as messy as it's going to get. You could tell that if we increase this number to, if we went bigger than 6, this thing's going to get huge really quick. So if we wanted to see if you knew how to generate maybe the 10th row of Pascal's triangle, one way that we can kind of ask you about it is to just ask you for a particular term. Now, if they ask you to find a particular term, then you don't have to do the whole thing. I highly recommend writing out the row of Pascal's to help, but you don't have to. So what I would recommend is, again, this here is telling you which row of Pascal's to use. Now, this one's not on the front, so I'm going to have to use my calculator to generate it. So I'll turn my calculator on, clear that. So I go to my y equals. So I want the 10th row. So you put in a 10, you hit the math key, you go over to probability, and then you choose choice 3, and then you put an X in. Then you look at the table. So the 10th row of Pascal's is 1, 10, 45, 120, 210, 250, 2, okay, and so on, right? Why did I stop? Because it was only asking me for the fifth. So that's like 1, 2, 3, 4. So this is the one that I'm interested in. So I just kind of rewrite that out, and then I do the thing where I put my two parentheses, and I'm going to have 2x in one of them and a negative y in the other. And the reason why I write out this row of Pascals is because it kind of helps me count down. I know that I start at a 10, so I just kind of say 10, 9, 8, 7. So the exponent here has to be a 6. And you can either say, I know that it has to add up to 10, so this has to be a 4. Or you could say, well, the second term starts with the exponent of 0. So it's 0, 1, 2, 3, 4. So the exponent there is 4. So now I don't have to like clean up the whole thing. I just need to kind of focus in on that particular term. So if I clean this up, I'm going to need 2 to the 6th power is 64, and I have to multiply that by 210, right? So times 210. So I get 13,440, and that was x to the 6th, y to the 4th. Notice that this is a negative 1 to the 4th power, so it just becomes a positive 1. So that's why this one's not negative. If this was an odd power here, then there would have been a negative I had to deal with. So that would be my answer there. Almost done, just one more example. So then find the coefficient of the x to the 7th, y to the 7th term of this thing. So now it's a little bit trickier. So again, I'm going to go back to my y equals. I want the 14th row of Pascals, so I'm going to kind of go in there, and I'm going to change it to 14th row of Pascals, and I'm going to look at the table now, and maybe I jot that down. Okay, so I've got it on there. I don't know if you can see. So it's 1, 14, 91, 364. Again, I like to kind of write them down. You might, since you have your calculator there, you might be able to count them from there. 2002. After 2002 comes 3003, and then 3432. Oh, I thought I was seeing a little pattern there, but okay. So I can keep going, but since I know that it's going to start at the 14th power, right? Because this was a 14, so I kind of count down. 14, 13, 12, 11, 10, 9, 8, 7. This is where I'm going to have that x to the 7th. So I'm going to say it's 3, 4, 3, 2. X, we said it was to the 7th power, and then I still need that 3y also. That would also be to the 7th power. How did I know? Because I know they have to add up to 14. The other way you could do it is start at 0. 0, 1, 2, 3, 4, 5, 6, 7. So from there, you clean that up. And if you clean that up, you get 3 to the 7th. That's going to be really big. So you're going to have your calculator. So 3 raised to the 7th power. And then I have to multiply that by 3,432. Ooh, look at that big old number. So we've got that to be 7,500,000. Oh, that's even more. Oh, 505,784. And then don't forget your variables. X to the 7th, y to the 7th there. Okay? Okay. So make sure that you can give me the coefficient on a particular term. Make sure you know how to identify an exact term. Okay? Here the answer, if it said find the coefficient on that term, the answer would just be this part. That would be the coefficient. Okay? Coefficient there. Okay? All right, and you've got your homework, and we just have one more day of new material before your test that's coming up in a couple days. Have a great day.